Math 76, lesson 109, corresponding parts of similar triangles. So, corresponding, that's a big word. We have to understand what in the world corresponding means. When we have two similar triangles, when we talk about corresponding parts, what corresponding means is they kind of match up, or they're related to each other, okay? And I can show you that with my triangles. So if you remember this triangle from the previous lesson, it now has a twin brother, right? Now these are two congruent triangles, right? They're congruent because I can place one on top of the other, and all the sides and corners and angles match up perfectly, right? And so that's how I know they're congruent. Now, in addition to being congruent, they're also similar. Now, similar shapes, if you remember, have the same shape, but they don't necessarily have the same size. In this case, they do have the same size, but we're going to use this similarity to find corresponding parts. So corresponding we can think of as like matching. So if I was to say which corner on this triangle would match with the corner on the other one, well, you would all say that one because it's that's the same size angle, right? And that's more or less how we're going to find corresponding angles. Corresponding angles are equal, or they're the same size. Now, what if I wanted to find the corresponding side? Like which side on this triangle, the red side, corresponds to the other triangle? We would say the other one, right? And it's easy to see because these triangles are both oriented in the exact same position. Now, what happens if I start turning them and rotating them, right? Now, what if I ask which side corresponds to this blue side on the other triangle? Well, we can think of it this way. Well, this is the shortest side, that's longer. These two are both longer, so if I find the shortest side over here, that corresponds. That's one way you can find it. But sometimes angles have sides that look really similar. It's hard to tell which one's shorter. So now we can compare the angles. If I wanted to find which side corresponds to the blue side, I'm going to find this vertex, right? And I'm going to think, how in the world did this triangle move to get that one? Well, it looks like it got translated, and it looks like it also got rotated, okay? So it got translated over here, and then it got rotated. If I do that, I can see this side matches up with that side. So that's another way that you can find the corresponding sides, is if you have similar shapes, you can kind of match them on top of each other to find the sides that correspond, right? So now let's talk about what if they're not the same size, right? So let me draw another triangle that corresponds and is similar but not the same. Okay, now I've got this smaller similar triangle. Now, if I wanted to find out which side corresponds to this red side, which side would that be on the smaller triangle? Well, to figure it out, I would have to, well, first I have to reflect this triangle, see, because it's facing the wrong way. So if I reflect it, now it looks like it's facing the right way. If I translate it over, I can see now, okay, those are the two sides that correspond, right? We can also do this with letters, right? So your book is going to use letter notation. We'll call this one A, B, C, and then we'll call this triangle, we'll draw this in pencil in case I use the shape again, X, Y, Z, okay? So, I've got angle Z, angle X, angle Y. Let's say I turn this one like this. Which angle corresponds to angle Y? Well, I would have to rotate it, slide it over, and then I can see that B corresponds to angle Y. So these are different methods that we use to figure out which sides correspond to similar shapes, right? Let's see here. Okay, now we're going to talk a little bit more about similar triangles and similar shapes, okay? So here we see four different, whoops, I forgot I'm supposed to do that. I have to press the zoom button. There we go. So here we see we have four different triangles, and we have to figure out which ones are similar. If you remember, I said similar polygons have the same shape, but not necessarily the same size, right? So if I look at these triangles, well, I can tell this one is definitely a different shape. These three, they all look like the same shape, but these two are smaller, right? So actually, let's see here. We see that 1 and 2 are definitely similar because they have the same shape. Is this one also the same shape? Yes, it is, because I can see these sides look equal and that side looks longer, and here these sides look equal. So all three of these shapes are actually similar to each other. So size is not a factor when it comes to similar shapes. the length and the shape or the size of the angles is a factor, and this one's not because it doesn't make the same shape. This triangle looks more like an equilateral, whereas these look like isosceles right triangles. Okay, let's see here. I think that's it for this lesson. Yeah, that's it. Just some math facts about triangles. If you guys have any questions, let me know on the school website, and I'll see you in class.